Classic soda is one of the most recognizable drinks on Earth. Fizzy, sweet, instantly familiar. Yet behind every bottle and can is a tightly controlled industrial process built around secrecy, chemistry, precision mixing, and massive high-speed bottling systems. What tastes simple is actually the result of water purification, syrup engineering, carbonation science, and one of the most closely guarded flavor formulas in the food industry. For more than a century, legendary sodas have been produced at enormous scale while maintaining the same taste across continents, climates, and generations. And today on The How Factory, we're going inside modern soda plants to see exactly how classic soda is made. Inside the factory that turns a mysterious multi-flavor formula into billions of identical drinks every year. The story of classic soda begins long before automated factories and aluminum cans. In the late 1800s, early sodas were sold at pharmacies as medicinal tonics, mixed by hand from syrups, herbs, spices, and carbonated water drawn from soda fountains. These drinks were often marketed as digestive aids, nerve tonics, or energy boosters. As popularity grew, certain formulas stood out for their unique balance of sweetness, acidity, spice, and aroma. Over time, these recipes became standardized, bottled, and scaled for mass consumption. As competition increased, protecting flavor identity became critical, turning soda formulas into some of the most valuable trade secrets in the world. Everything starts with water, because soda is mostly water. Before anything else happens, incoming water is purified to an extreme level. Municipal water is not clean enough on its own. It passes through multi-stage filtration systems that remove sediment, chlorine, organic compounds, dissolved minerals, and microscopic contaminants. Reverse osmosis membranes may be used to strip the water down to near chemical neutrality. The goal is total consistency. No matter where the factory is located, the water must behave exactly the same way when mixed with syrup and carbon dioxide. Even tiny mineral variations can change how flavors are perceived on the tongue. Once purified, water is stored in stainless steel tanks and continuously circulated to prevent stagnation. Temperature is carefully controlled because cold water absorbs carbon dioxide more efficiently than warm water. Sensors constantly monitor conductivity, temperature, and purity. The water system is the backbone of the entire plant and operates continuously as long as production is running. While water is being prepared, the flavor system is handled separately under strict security. Classic soda flavor is not openly mixed on the production floor. Instead, a highly concentrated flavor base arrives at the plant from a central, tightly controlled source. This concentrate may include citrus oils, spice extracts, herbal compounds, and synthetic flavor molecules, all dissolved into alcohol or other carriers to preserve stability. Only a very small group of people worldwide ever know the complete ingredient list or proportions. At the factory, the flavor concentrate is combined with sweeteners to create syrup. Historically, cane sugar was the primary sweetener, and in some regions it still is. In others, high fructose corn syrup is used because of cost efficiency and shelf stability. Sweeteners arrive in bulk tankers and are stored in heated tanks to keep them fluid. Before blending, they are filtered to remove any particles that could affect taste or clarity. Automated blending systems meter exact amounts of flavor concentrate, sweetener, and acids into large stainless steel mixing tanks. This syrup is extremely concentrated, thick, dark, and intensely aromatic. It is far too strong to drink on its own, but it represents the core identity of the soda. The syrup stage is where flavor consistency is locked in. Quality control at this stage is relentless. Samples are tested for sweetness, acidity, density, color, and aroma. pH levels are adjusted using food-grade acids, often phosphoric acid, which provides soda's sharp bite, or citric acid, which adds brightness. These acids also help inhibit microbial growth. Even a tiny imbalance can change how carbonation feels or how sweetness is perceived, so adjustments are made before syrup is approved. Once the syrup meets specifications, it's transferred to the bottling hall, where it meets water at incredible speed. Modern soda plants use inline proportioning systems that mix syrup and water in exact ratios, often around 1 part syrup to 5 parts water, though this varies by brand and region. Flow meters, pressure sensors, and automated valves ensure accuracy down to fractions of a percent, even as thousands of liters move every minute. Next comes carbonation, the defining feature of soda. Carbon dioxide gas is delivered to the plant in pressurized tanks or generated on site. Before injection, the water syrup mixture is chilled to near freezing temperatures. Cold liquid absorbs gas more efficiently, creating stable bubbles. Carbon dioxide is injected under pressure through carbonators that dissolve the gas into the liquid uniformly. The carbonation level is precisely controlled. Too little gas makes the drink flat. Too much creates harshness and instability during filling. At this point, the soda itself is complete, but it still hasn't been packaged. The finished beverage flows directly into filling machines through sealed pipes to prevent gas loss. Bottles and cans arrive at the line empty and must be cleaned first. Bottles are rinsed with purified water or sterile air. Aluminum cans are inverted and blasted with ionized air to remove dust and metal particles. Cleanliness is critical because even microscopic contamination can affect taste or shelf life. Filling happens at astonishing speed. Modern lines can fill tens of thousands of bottles or cans per hour. Filling occurs under pressure, so carbonation stays dissolved. Valves open and close in milliseconds, delivering precise volumes into each container. Liquid-level sensors ensure visual uniformity, so every container looks identical on store shelves. Immediately after filling, containers are sealed. Cans are sealed with lids using high-speed seamers that roll aluminum edges into airtight joints. Bottles receive caps that are applied and torque-tested automatically. Sealing must happen instantly. Delays allow carbonation to escape and oxygen to enter, reducing freshness. Once sealed, containers pass through inspection systems. High-speed cameras check fill height, cap placement, and label alignment. Pressure sensors detect leaks, while automated reject arms remove defective containers without slowing production. Every bottle that reaches consumers has passed multiple checks in seconds. Labeling and secondary packaging follow. Bottles receive paper labels or shrink sleeves, while cans are often pre-printed. Date codes and batch numbers are applied for traceability. Containers are grouped into multi-packs, trays, or cartons. Robotic palletizers stack cases with precision, creating uniform loads for transport. Sanitation runs continuously in the background. Soda plants use clean-in-place systems that flush pipes, tanks, and fillers with hot water, and cleaning solutions between production runs. This prevents flavor carryover and bacterial growth. Even though soda is acidic and shelf-stable, hygiene standards are extremely high. One of the most remarkable aspects of classic soda production is consistency. A soda made today must taste exactly the same as one made decades ago, even if it's produced thousands of miles away. This is achieved through centralized flavor control, standardized equipment, constant testing, and trained operators. Samples are tasted, measured, and compared against reference standards multiple times per shift. Sustainability is increasingly important. Plants reduce water usage, recycle rinse water, recover carbon dioxide, and use lighter packaging to cut emissions. Many facilities operate closed-loop systems and recycle aluminum and plastic at massive scale. What makes classic soda manufacturing so fascinating is the contrast between mystery and machinery. The flavor formula remains secret, but the production process is a triumph of industrial engineering. Designed to move liquid faster than almost any other food product while maintaining perfect taste and texture. From purified water and guarded flavor concentrates to syrup blending and carbonation, from high-speed filling and sealing to automated inspection and global distribution, every step is engineered for speed, precision, and consistency. And that is exactly how classic soda is mixed, carbonated, bottled, inspected, and shipped, turning a legendary multi-flavor formula into billions of perfectly consistent drinks enjoyed around the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories, machines, and systems behind iconic everyday products.